All right, matrix, we're just going to do St. Andrews, paper 1, 2016, question 13 and question 14. And there. Okay. So, question 13. Okay, so we've got this cubic function over here. Okay. And it's checking that you really understand notation. So this first question says, when is f of x equal to 0? F of x means when are the y coordinates equal to 0. And the y coordinates are 0 over here and over here. Okay, so the y coordinates are equal to 0 at x is equal to -1 and x is equal to 3. Okay, so that's where your y coordinates are 0. Now f dashed of x gives you your gradient. So they're asking you, where is your gradient equal to 0? Now your gradient is equal to 0 at the turning points. So it'll be at that point over there and at that point there. They want to know the x values where that happens. So it will be x is equal to -1 and or x is equal to 5/3. Okay, x is equal to -1, x is equal to 5/3. Okay, the next one has to do with second derivative. Okay, so second derivative, where the second derivative is not, is your point of inflection. And your point of inflection, if there's two stationary points, it's in the middle of the, between the two, halfway between the stationary points. So it's the middle of your stationary points. And we worried about x coordinates. So you're going to take the two x coordinates, add them up and divide by 2. So it'll be -1 plus 5/3 all over 2, which is going to be 5/3 minus 3/3, which is 2/3. And 2/3 divided by 2 is 1/3. So it should be 1/3, right? That's going to be that coordinate over there. Okay, we're at 1/3. Right. The next one. Okay, so x is equal to 1/3. Because your point of inflection, remember, is where it changes concavity. So that is the point. Okay, so it's in the middle. That x coordinate plus that x coordinate divided by 2 gives you this x coordinate here is going to be 1/3. The y coordinate will also be in the middle, but they didn't ask you for that. Okay, there's your point of inflection. Okay, so remember, what is a point of inflection? It's where the graph changes concavity. It's changing from that's concave down to concave up. Okay, the next f of x means the y coordinates, and here it's saying to you, when are your y coordinates bigger than 0? So your y coordinates are bigger than 0. So let's go from left to right. Here your y coordinates are negative. Okay, there it's 0, but we can't have 0. Here the y coordinates are negative. The only place where they're bigger than 0 is this last little section over here. Okay, where does that happen? It happens from here to there. Okay, so this is where your y coordinates are bigger than 0. So always highlight the part of the graph, then highlight, there's your answer on the number line. Okay, so when are your y coordinates bigger than 0? To the right of that. So when x is bigger than 3, or you could write x is an element of 3. You can't include 3 because it's bigger than 3 to infinity. Okay. Right, the next one is when is f dashed of x bigger than 0? That means when is the gradient positive? Okay, when is your first derivative positive? Means when is your gradient positive? So when is this graph positive? It's positive from here to here. So where's that from on the number line? Okay, I can't include that point because there the gradient is 0. So it's from there down. So that's the first region where your gradient is positive, where f dash x is bigger than 0. So your first answer is x is an element of -infinity up to -1. You can't include -1 because at -1 the gradient is 0 and I just want bigger than 0. Okay, then the gradient, and then the gradient is positive again from here to here. Where does that happen on the number line? Well, here the x coordinate is 5/3, so it's from 5/3 outwards. Okay, so or from 5/3, I can't include it because it's just greater than, up to infinity. You could also write it as an inequality. You could say x is less than -1 or x is greater than 5/3. Okay, there is your answer for that. Now we're looking at concavity. This means when f dash second derivative is positive, means when is the graph concave up? We're on the smiley part of the graph. In other words, the part of the graph, okay, where the tangents are below the curve. So here, this is your concave down because the tangents will all be above the curve. So this is concave down, changes to concave up at your point of inflection. So the green part over here, that is where the graph is concave up. Okay, so where does it go from? It goes from which x coordinates does it happen? Okay, well there's no, we said that it's not at the point of inflection, it's not concave up or concave down, so we don't include it. So from there outwards, so from when x is equal to a third, there's your answer on the number line. Okay, so when's the concave up? When x is greater than a third, or you could write x goes from a third to infinity, right? That's when the graph is concave up. Now you're combining it. They want to know if you times two things together. So either to get a positive answer, you want the answer to be positive. They're saying when is f of x times f dash of x bigger than 0? So then either your y, they want to know where the y coordinates are positive and at the same time gradient is positive. Does that happen anywhere? Because that'll give us a positive answer. Or they want to know when are the y coordinates negative and at the same time the gradient is negative, because the negative times the negative will give you a positive. So let's have a look what's going on. Here, the gradient is positive. Okay, so f dash of x is positive, but f of x is negative. If you times them together, okay, you're going to get a negative answer. We want positive answers. There, that's naught. After -1, the y coordinates are negative and the gradient's negative. So here in that yellow region over there, f of x is negative, the y coordinate's negative, and the gradient's negative. You times them together, negative times the negative will give you a positive. So your first answer, where that happens, it might be the only one, is x is an element of, it's got to be bigger than naught, so we can't include it, from -1. So this is your answer in the number line, from here to here. So from -1 to 5/3. So -1 to 5/3, there's your first answer. X is an element of -1, 5/3. Okay, and then they want to know, okay, then afterwards what happens? Well, here your gradient is positive and your y coordinates are negative. Okay, so if you times into the negative, that's not what I want. But over here, once again, your gradient is positive, okay, and your y coordinates are positive. If you times them together, you'll get a positive answer. So your second region is all x goes from 3 to infinity. So your answer for 7, -1 to 5/3, or 3 to infinity. Right, the next question says, write down the coordinates of point A under the following transformation. Well, f of x minus 4 means the whole graph moves 4 down. So point A, if it moves 4 down, the x coordinate will still be -1 and the y coordinate will be -4. So this one will be, so A transformed will be -1, -4. That's that point over there. Here means it's the inverted point. Okay, on the inverse. Okay, so on the inverse, what do? We swap the coordinates around. So on the inverse, the coordinates of A, instead of being -1, 0 will be 0, -1. Okay, that'll be your inverse. Okay, right, and the last one, determine the equation of this graph. Now remember, in general, when you're given the x-intercepts of a cubic graph with the 3 x-intercepts, then the form of that equation is y is equal to a x minus x1, x minus x2, x minus x3. So if you're given 3 x-intercepts, you'd replace x1 and x2 and x3 with the x-intercepts. You'd then have to be given another point, xy, you'd sub that in, you'd solve for a. So your objective is to replace a, x1, x2, and x3 with numbers, right? Okay, so there you'd sub in the intercepts, sub in another point, solve for a, and go back and write it like that. Here, there is a case, though, where if you know, like a situation like this, if the x-intercept repeats itself, so you've got some graph that might do this, and let's call it x1, if it turns on the x-axis, so that's an x-intercept and it's a turning point, okay? If it turns on the x-axis, then what we think of is that this slows down at the turning point, so it touches the curve at 2 points. So this point over here repeats itself. So in that case, this point repeats itself, and we say that the formula is y is equal to a, I'm going to go over here, sorry, y is equal to a, x minus x1, and it repeats. That one where it touches at 2 points, that repeats. So it'd be a x minus x1, x minus x1, x minus x2. Okay, so here, in other words, y is equal to a x minus x1 squared, x minus x2. That's your general formula if it turns, one of the point turns on the x-axis. See how we've got that scenario. This turns on the x-axis. So the formula of the equation is going to be y is equal to a, okay, x minus, if we call this one x1, x minus x1 squared, because it's going to slow down and repeat itself. So it's x minus x1, x minus x1, times by, and we call this x2, x minus x2. So that's your general formula. Okay. And in this particular case, this one's going to repeat. So you get y is equal to a x plus 1 squared, okay, x minus 3. Okay. Right, but now we've got to figure out a. We know a must be positive because it starts with a positive and ends with a positive. So I must have another point. I've got another point in the graph. It's 0, negative 6. So sub in 0, negative 6. And I get negative 6 is equal to a 0 plus 1 squared, 0 minus 3. So therefore negative 6 is equal to, that's 1, that's negative 3, negative 3a. Divide by negative 3, and a is equal to 2. Okay, so a is equal to 2. So if I go back to your general over here, I end up with y is equal to 2 x plus 1 squared times x minus 3, and that is the equation. They didn't ask you to times it out. Okay, they ask you to times it out, you square it out first. Okay, then times it by x minus 3, then times it all by 2. Okay, but there's your answer in that format. Okay, question 14. Okay, right, it says in the diagram, ABC is an equilateral triangle with the sides are 12, okay, and this is a rectangle. This is, so because equilateral, guys, that'll be 60, that'll be 60, and that'll be 60, okay. Then we've got a rectangle and where they say that BE is x and FC is x. So if that's the case, then this distance over here must be 12 minus 2x. That's the length of your rectangle. So it says, showing or working, prove that the area of the rectangle is that. Okay. So an area of a rectangle is equal to length times breadth. Well, we know the length is 12 minus 2x. Okay, so that's that bit over there. So hopefully we can show the height over here, or the breadth, is equal to root 3x. So the trick is, well, you've got that triangle over there, right? And in that triangle, this is 60 degrees, and this is x. Okay, so how can we find this height in terms of x? Well, we know in a right-angled triangle, SOHCAHTOA, tan is equal to opposite over adjacent. So I've got the opposite. X is the adjacent. I'm looking for the opposite. X is the adjacent. So I'm going to say tan of 60 is equal to opposite over adjacent. Opposite 60 is h. Adjacent to 60 is x. Okay, so it's h over x. And tan of 60, you can check on your calculator. Tan 60 is equal to root 3. So you've got root 3 is equal to h over x. So root 3 times by x is h, divide by root 3. Sorry, that's it, I'm done. So h is equal to root 3x. Okay, so your height is root 3 times x. Okay, so that's root 3 times x. So then the area of the rectangle, the area of that rectangle is going to be length times breadth, okay, which is root 3x times by 12 minus 2x. So that's your answer for A. For B, okay, remember they asked the question like this because if you can't do that, you must still use that for B. So to maximize something or minimize something, remember a maximum or a minimum occurs when your gradient is naught. What's your gradient? Your gradient is your derivative. So a maximum or minimum question in paper 1 will always have to do with when your gradient is equal to naught. So we've got an equation. We've got A is equal to root 3 x 12 minus 2x. The maximum will occur when dA dx is equal to 0. But I can't differentiate yet, so I'm first going to have the times out. So I'm going to area is equal to root 3x times 12, which is going to be 12 root 3x minus 2 root 3 x squared. Okay, so now I can differentiate. So now I can say, therefore, I want to solve dA dx is equal to naught. dA dx be the coefficient of that, 12 root 3 minus 4 root 3 x to the 1, and I want to know where that's equal to naught. So you get negative 4 root 3 x is equal to negative 12 root 3. So x is going to be equal to negative 12 root 3 over negative 4 root 3, which is equal to 3. Those cancel, negative 12 divided by, so I end up with x is equal to 3. So the area we maximized, so the maximum, so that's the end of B. So the maximum area happens when, so in C they want to know what is the maximum area. Well, we know that they gave us a formula for the area. The area is root 3 times x 12 minus 2x, but the maximum occurs when x is equal to 3. So the maximum area will be root 3 times 3, 12 minus 2 times 3, which is 3 root 3 times 12 minus 6 is 6, so it's going to be 18 root 3. Okay, double check about that. Yep. Okay, so area is equal to 18 root 3. So any maximum minimum question, okay, what's your process? You've got to get what you're trying to maximize or minimize in terms of one variable. Once you've done that, a maximum or minimum will occur when the gradient is equal to 0. Okay. If they then ask you to maximize the area, you put whatever the x value is back into the formula. All right, guys. Thank you.